Okay, so we're going to be answering some of the group questions. Today we have 7 questions. I'm going to be starting with group 1. So basically, their question was, what industries would make the biggest impact if they change some things? So, a few of the answers were oil and gas, agriculture, or waste management. So the answer to that question would be the oil and gas industry because they use pipelines, that contain valves and controllers. And what they do, what's bad about them is that they cause a lot of vents and leaking. And when that happens, it leaks into the Earth's, it leaks into our atmosphere, because they use pressurized natural gases, which would example be methane. So, that would be the biggest cause of, the biggest impact would be oil and gas. And then if you wanted a second one, it would be waste management for that one.
Hello. Thank you, Group 2, for your great question. The answer to that is yes. Engineering companies are regulated to not produce high levels of methane. Firstly, they are mandated to have frequent inspections to find and fix any methane leaks as quickly as possible. They are also required to have up-to-date tools and equipment that have low emission levels, or are required to install vapor collection systems for equipment that they don't have a low emission alternative. They must also prioritize using air or electric powered tools over pneumatic, or again, if not possible, they must set up vapor collection systems for if there's no other alternative. As a final incentive or regulation, the engineering companies are also required to report on their equipment and emissions, as well as any results from flash tests to show compliance with the set standards, and they are fined if they do not meet these requirements. Thank you.
And then I'm also answering group three's question about, um, if methane was reduced today, what difference would that make in 10 to 20 years? So reducing methane today would make a difference in 10 to 20 years by a lot because methane stays in the air for about 12 years in the air in the atmosphere. So doing this, we would lower a lot of the heat that Earth traps, and then it would also improve our air quality and reduce, like we said in the presentation, methane is linked to ozone, so it would reduce the ground level of the ozone. And then in our slides, you can see our diagram and our picture of the ozone connecting to methane. So we would have fewer extreme heat events also.
Okay, so I'm going to be answering group four's question, clarifying how methane interacts with NOx levels in urban areas, and how those under what conditions does reducing NOx actually increase ozone? So for the first part of that question, so essentially, um, our contaminant, methane, is considered a VOC, and NOx just constitutes nitric oxides. And sorry, so these are precursors to ozone because they interact together to produce ozone through a secondary reaction, with which essentially means that they're already in the atmosphere um, through their different sources. So NOx is emitted through combustion reactions, whereas methane in particular is sourced through agriculture and like the burning of fossil fuels, let's say. Um, so that kind of answers the pathways. As for the conditions where reducing NOx actually increases ozone, so I'm gonna pull up the graph from our presentation real quick, right here. So as we can see by looking at this nonlinear distribution, so if we were to simply decrease VOCs or decrease NOx, that wouldn't necessarily decrease the production rate of ozone. Um, and this is essentially because NOx and VOCs react through a photochemical reaction, which requires sunlight to kind of expedite that process. where the sunlight breaks down the oxygen molecules, and then those oxygen molecules are then free to um, react with one another and create O3 or ozone. So NOx um, in urban areas is can still be available and abundant, whereas VOCs can be more limited in urban areas due to urban areas being like cities with really dense populations. So when there's less VOC in the air, NOx will then react with um, the ozone that's in the atmosphere through NOx titration, and then that will reduce the productions of ozone. However, if we were to simply reduce NOx by itself, there would be less NOx in the air to react with ozone and to reduce that production. So essentially, reducing NOx can actually increase the production rate of ozone because there's less NOx in the air to reduce it, if that makes sense. All right.
I will be answering group 5 and 6's question. The first part of group 5 and 6's question actually are kind of similar. It's pretty much just asking like, what are the um, what are the positive uses of methane and how can it be used as a sustainable energy source? So I'll be talking about the first parts of both questions first for 5 and 6, for group 5 and 6. So methane can be used sustainably as a fuel source for cars, for heating, for energy, and especially for cars specifically. Actually, no, not for cars specifically, but like just in general, it could be used as a it can be methane can be captured and compressed into a natural gas called CNG, compressed natural gas. And there are cars that are powered by this. There are cars, buses, trucks that are powered by CNGs. And this type of fuel, this type of fuel source creates less pollutants than gasoline or diesel cars specifically. And methane can be captured from as biogas from landfills and wastewater treatment plants and even agricultural waste like manure. And when cleaned, it becomes what is known as renewable energy source, so RNG, or renewable natural gas, sorry, as RNG, and it can be used for heating, electricity, and fuel for vehicles. And uh, yeah, that's like the positive. That is like from my research. That is basically like some of the uses for methane to be used as like a um, sustainable type of uh, energy. And to answer the second question of group 5 now, so going back to group 5, um, are there efforts to make rice cultivation and other large food sources emissions sustainable? So, um, a solution that I was reading would be to just reduce the use of water and the times water is being used for agriculture and specifically like for rice cultivation. I keep rolling my keep messing up on that. But for rice cultivation, pretty much just like periodically use less water because as more water is being added, more of biomass or plant organisms are decomposing, which is adding to the contribution of methane emissions. So periodically using less water and using less manure um, uh, can decrease methane emissions from rice cultivation. And to answer the second question of group 6, um, it's regarding why aren't there any um, why aren't there any uh, sorry, hold on, I'm having trouble. If there are many positive uses for methane, such as methane cars, and if there is more, why don't we see it being used? Part of that, oh yeah, so the question is like, why don't we see methane being used more often as like an energy source? Um, One of the reasons too is like methane leaks can be very high, or methane leaks are highly damaging because it's a very potent greenhouse gas, especially when it's released into the air. And a lot like when methane is released, it, as I said earlier, and as mentioned earlier in the presentation, it can contribute to um, tropospheric ozone, which leads to health complications, environmental complications too. And building methane-based fueling system is very expensive too because it's because of how uh, how like in the same way like how back then Tesla chargers were kind of a newer thing and like being slowly added all over the world. If we're adding a new type of energy source for fuel, um, it's very expensive to be integrating that, especially into like everywhere pretty much. Like it's just very expensive in general to uh, integrate that pretty much. So yeah, that hope that answers your question.
All right, so now to answer group seven's question regarding the decomposition of methane. So it was I'm not entirely sure if we did mention hydroxyl radicals, um, but I'm glad that you guys brought that up because that's actually pretty important when it comes to the decomposition. So hydroxyl radicals and NOx are completely separate, but hydroxyl radicals are essentially like OH, but they have a um unbounded element to them. So that essentially means that they're a really good detergent. So they're really good at cleansing our atmosphere and water by oxidizing and like breaking down pollutants like VOCs. So that's actually very that could be helpful in the future for reducing ozone production. But where we were focusing more so on was on the relationship between VOCs and NOx as opposed. And so NOx again is essentially just a classification term for NO and NO2. And I apologize, I did misspeak when explaining this part. So through NOx titration, I had initially said that NOx in the air would react with ozone in the absence of VOCs and sunlight and such to then produce carbon dioxide and oxygen. That was completely wrong. It was nitrogen dioxide and oxygen. So through the reaction, the the NO2 or NO that's in the air will react with the O3 molecules. Um, and in fact, when NOx is released, it immediately does this before interacting with like VOCs or anything else. So when NOx is freshly released into the air, it will remove the ozone immediately surrounding it. However, after this, it can then be used again in combination with VOCs and sunlight to produce even more ozone. So that's why the graph distribution that we have shown was non-linear because it's kind of fluctuating when releasing NOx into the air. It reduces ozone immediately, but then it's also part of that equation to produce more and more ozone with VOCs. But again, like you guys have said, hydroxyl radicals could be further like implemented and used for reducing VOCs, which then in tandem with reducing NOx could overall reduce the production of ozone in the atmosphere. So I hope that clarifies that part.